Hello everyone, welcome back to MAC1140. Today we're going to jump to chapter 8. In this chapter, we'll be talking about another branch in mathematics. We're talking about analytic geometry. Analytic geometry was found by a Greek mathematician named Apollonius. He's a Greek guy, and he lived around 240 BC, so pretty long time ago. He considered as a founding father of analytic geometry. And what is analytic geometry? Of course, this is geometry, right? And in analytic geometry, we will be discussing about a conic curve. Sometimes we call it conic section. So in this chapter, chapter 8, I want to talk about conic curve. Okay. What is conic curve? What is conic curve? Actually, in college algebra, you were introduced to two conic curve already. Probably at that time you don't know it's conic curve. One of the conic curve is the circle. The other one is parabola. But in pre-calculus, we'll be discuss two more conic curve, and we will want to take a look. We want to take a deeper look at the circle and the parabola also. And the third conic curve is hyperbola, and the last one is the ellipse. Okay. So in the first section, section 8.1. Okay. I will be discussing a circle and parabola. Okay, we'll be discussing circle and a parabola. This conic curve actually is nothing but intersection. Okay, intersection between a cone. So let's draw a cone. So if I have a cone like this. Okay, let's draw the cone like this. Okay. Okay, so I have a cone like this. Okay, so this is a cone, right? Yeah, okay. So the circle is a conic curve, and this is an intersection between a cone and a horizontal plane. So I have a horizontal plane, and it cut the cone, the cone. So my plane like this, my horizontal plane. Okay. Okay, and it's gonna cut. Okay, so it's gonna cut the cone. You see the intersection right here. You see that? So this is the circle. Okay, so this is a circle. Okay, this is a circle. A horizontal plane cutting the cone. And parabola is what? It's the intersection between a cone, okay, and a slanted plane. So I have a slanted plane like this. Okay, I have a slanted plane like this. Okay, and it's gonna cut a cone. Here you go at the parabola curve. Okay, something like that. Okay. I will be drawing two more pictures when we will be talking about ellipse and hyperbola. But in the first part of this lecture, in section 8.1, I will be discussing again conic curve, circle. I will be talking about circle again. Actually, in college algebra, you already learned what circle is, right? But in pre-calculus, we're gonna do more problem, harder problem related to circle. What is circle? Okay, a circle is nothing but a collection. It's a collection of points, okay, equidistant from a fixed point, and that fixed point here we call a center. Okay, so we have a collection. So you have a fixed point like this, right? And we have a bunch of points. We have a bunch of points, a collection of points. Okay, all the infinite many points over here will create a circle, and the distance between the fixed point and the point inside this collection is called radius, right? So this is called the center, right? That's called the center. And we also learned that circle can be written in with two equations. Okay, the first one we call general equation, general form of circle. And what is general form of circle? We already know that general form of circle is x squared plus y squared plus ax plus by plus c equals 0. So that is the general form of a circle. Okay, for example, we can have something like this. Let's see. I can give you a quick example. I just want to make sure that the example I give you is a circle. So I can have something like this. I can have like x squared x squared plus y squared plus 10x minus 4y plus 33 equals 0. So this is the general form of the circle. Okay, and we also have another form. We call that standard form. We have a standard form of the circle. Okay, and the standard form it will be related to the coordinate of the center. So given a coordinate of center, so coordinate O, I, the center I, with coordinate is A and B. Okay, then the standard form of the circle will be x minus a squared plus y minus b squared r squared. Sometimes they use h and k. Okay, so a and b, it doesn't matter. You can use h and k. Okay, for example, r in this case the radius. Okay, so I'm gonna write capital R right here. For example, I have something like this. I have x minus the 3 square plus y minus 2 square equal 9. So if you look at the standard form of the circle, you know right away the center will be will have coordinates 3 and 2, right? And we have the radius will be 3 because it's r squared, so 9 is 3 squared, so the radius will be 3. Okay, the radius will be 3. Okay, so we can convert between general form to standard form. You see that if they give you the general form, you see that it's very hard for you to get the coordinate of the center. Right? It's very hard for you to find the radius. However, we can convert between general form and standard form. Okay, for example, you see that in the first example here, it's in the general form, and you don't know what the coordinate of the circle, right? But you can convert it to standard form so that you know the coordinate. Okay, but before doing that, I just want you to notice this. So if A and B equals 0, then my equation become x squared, right? So the 0 0 here, right? 0 0 here, so we have x squared plus y squared equal r squared. So this is the equation representing circle with center. So center circle with center 0 0. Okay, and with radius r. So this circle here has the center right at the origin. Okay, circle here has the center right at the origin, and they have the radius r. Okay, so if A and B equal to 0, well, it totally makes sense. Okay, all right. So in the next example, in example number 3, I will show you how to convert general form to standard form. Okay, so that you know the coordinate of the center and you know the radius. Okay, so how are we gonna convert it? Excuse me, I have very bad allergy. So how are we gonna convert it? Very easy. So we're gonna use completing the square. Remember the method we already learned in college algebra. We're gonna do completing the square. It means that we try to bring it to the perfect square. Okay. So the first step you have to do is you're gonna group all the term with x together and all the term with y together, and you're gonna bring the constant to the right hand side. So the step of completing the square is that we're gonna take the coefficient in front of the x and in front of the y, we divide it by 2 and we square it. So we're gonna take this divided by 2, it gives you 5, right? And you square it, give you 25. Okay, same thing over here, you divide it by 2 and you square it, give you 4, and you're gonna add 25 and 4 to the right hand side. Okay, afterward you see the first 3 term here, it will give you the perfect square. So this is a perfect square right here. This is x minus 5 squared. Okay, and this one is nothing but y minus 2 squared equal to negative 33. Oh, let me see, there's something not dry around here. So we have you see that we have a negative 33 plus 25. So 20 is 25, so it's 29, right? Minus 33 is negative 4. And you see that this doesn't make sense. So I think I'm gonna change a little bit. So I'm thinking I'm gonna change this to negative 33. So let's change this. Okay, so maybe there's a mistake. So it's negative. So we cannot have negative here. So this is positive 33. So positive. So we have 33 plus 24. plus 25 plus 4 will be plus 29, so give you 62. Okay, so you see that I successfully converted general form to standard form. That's why I can get the center. I can get the center is 5.2, and we have the radius is square root of 62. Okay, radius square root of 60. So that is the way you convert between general form to standard form. Okay. Alright, example 4. Alright. In example number 4, I will show you how to write equation of circle by using the standard form or general form, but most of the time it's easy to write equation of circle with standard form. Okay, but in order to do that, we need to find the center and the radius, right? Okay, now let's take a look at this one. Okay, let's see. Sorry. Let's take a look at this one. Let me give you this problem. Okay. I want you to write equation of circle. Okay. Which has center I is 2, -3, and this circle goes through 1, 3, 4. Alright. So how will you do that? Okay, because I prefer the standard form. So I'm gonna use standard form. So for the standard form, just go ahead and write our standard form first. So the standard form is x minus h squared plus y minus k squared equal r squared, right? You can use a and b or h and k, it doesn't matter. Okay, so they give you the center already. Okay, they give you the center already. It is h and k. So you see that I can replace it in h and k with 2 and -3, so it becomes x minus 2 squared plus y. K is negative, so we have another negative here, so it becomes positive 3 squared equal r squared. Okay, but the thing is that you need to find radius, right? You need to find radius. Okay, so we're going to use this information. So they say that the circle goes to 1, 3, 4, so we're going to plug 3, 4 into x and y, so we have 3, 4 equal r squared. Then from here, after you plug in, you see that we can find r easily. So give you 1 squared is 1, is 49 equal r squared. So r squared equal to 50. Alright, r squared equal to 50. So it means what? It means r is square root of 50. R is square root of 50, right? So after you get r already, hold on, let me close this. So after you get r already, you see that you can rewrite the equation, right? You can let me see there. I'm sorry. Okay, so after you get r already, you see that you can get the final answer. The equation will be x minus 2 squared plus y plus 3 squared. R squared will be 50. Okay, very easy. Very easy. Alright, how about this one? How about this one? Example 5. Drawing equation of circle okay, that goes through 3 points. The first point is 1, 4, second point is -7, 4, and the third one is 2, -5. Alright, so when you're dealing with the question like this, you should use the general form. That's much easier. So you know the general form is x squared plus y squared plus ax plus by plus c equals 0. So what you have to do is just go ahead and plug them in. So you can have the first one 1, 4, right? So you have plugged it in, so you can have 1 square plus 4 square plus a plus 4b plus c equals 0. Okay, and then your equation could be a plus 4b plus c, all right, equal 16 -17, right? So that's the first equation, and you do the same for point B. So you're gonna have what? You're gonna have -7 square plus 4 square plus -7a plus 4b plus c equals 0. So give you 1. -7 square is 49. That's plus 16 minus 7a plus 4b plus c equal to 0. So your equation will be 7a, right, minus 4b minus c equal to 49 plus 16 is 65. Okay, so you have two equations, and you do similarly for c to -5. You will see that you have another equation is 4a minus 10b plus c equal 29. So you have the first equation, you have the second equation, and you have the third equation, and you see that this is a system of 3 variables. So this is a system of 3 variables. You already know how to solve it. You can do substitution, elimination, or you can use matrices. We already learned how to use matrix, the inverse matrix, or you can set up the matrix equation, and you can do the row reduced echelon form. Then finally you will get A, B, and C. Okay, so I'm gonna go ahead and skip that step, and after you solve it, then you're gonna get A is -3, your B is -1, and your C is -31. Then you will get your final answer. Okay, then your final answer will be what? Your final answer will be x squared plus y squared minus 3x, right? Plug them in. Minus y minus 31 equals 0. So I'm not going to skip the step of solving the system. Okay, I assume that you already know how to solve the system by using matrices or using Gauss reduced echelon form. You already learned how to do that, so you can solve A, B, C easily. All right. So basically that's the example for the equation. Of course there's more problem, the Harper problem, but I don't think that is the requirement in this course. I mean, I can create for you something interesting, but you don't have enough time to do, especially on the test. But oh no, maybe on the assignment I create something interesting and it requires you to think more. Maybe I give you something with like the intersection between the line, the circle, something like that, or the intersection between two circles, something like that, and you can get. It could be more interesting if I wanted. I mean, I can add those interesting problems to the assignment. It might be on the test. It might be on the test. I mean, I'm not gonna say it won't be on the test, but it might be on the test. But this example here, it just gives you the standard. It just helps you to understand the theory. Okay. But you know that math is very flexible. You know, I can give you something so that you can train so that you can train your logical thinking. But this, as long as you grasp the basic example right here, I'm sure that you can do harder problem. Okay, so I think I'm gonna stop the first part of this chapter, this section 8.1. On the second part, of this lecture, I will be talking about parabola. Okay.